point, we've been finding the area of a triangle by doing base times perpendicular height by 2, divided by 2, yes? So that's how we've been finding the area of a triangle up to now. But in order to do that, we need to know both the base and the perpendicular height. And the perpendicular height is not always something that is given to us. So this rule enables us to find the area of any triangle. Yes, totally. That's what I said. Yes. So if you have that information, you can totally use it. But if not, you can use this here. Okay. What's the matter, Mia?
Oh no, I'm just confused because then like the list you can just like what would be the perpendicular height for like a straight line or something?
So remember, to have a perpendicular height, you need to know. So if this, you know this measurement here, you'd have to know this measurement here to make a right angle with it.
Right.
And you're not always given that.
Okay, but if you did that, then you have to do it twice. No, you wouldn't. Okay.
You're given what twice?
Never mind. How about we learn it first?
Alright, so the area rule enables you to find the area of any triangle as long as you have an angle and the two sides surrounding it. Okay? So if you have an angle and the two sides surrounding it, you can find the area of it. Oh, do you know what? Okay, because I've circled there, I'll write it differently. So we can say that the area is a half BC sine A. Now, it's not written like that in your formula booklets. In your formula booklets, it's written a half AB sine C. But remember, my big thing is that labeling is not important. It's the positioning of your information that you've been given. It's the important. So in the formula booklet, you have half AB sine C. But that would work the same thing. As you can see, A and B are surrounding angle C, so the rule works. Okay, so if you have two side lengths and the angle surrounding it, you can find the area of the triangle. Now, in some questions, you have to find one of those bits of information first by using the sine or the cosine rule. Okay, so it's not always straightforward, lovely jubbly, you just have to do that. Sometimes you have to work a bit harder, but usually it would indicate that there's a part A and a B to the question, and you may be using the bits of information you found already. So, no, to use this rule you need to know any two sides and the included effort, that's what that means. If you can see a right angle triangle, or a right angle, and know the base length and the perpendicular height, you can still use that. So if you've been given that, don't stress about using the sine rule. You can just use that rule there.
Based on the longest side?
Not always. So that's the thing. So had I been given this side measurement here, in order to find the area of this triangle, I would need to know this height here.
Basis whatever the perpendicular height intersects.
The height has to be perpendicular to the length that you are looking at.
Okay, well base can be any.
Base can be any of them, because obviously you can spin your triangle round, but your height must be perpendicular to it. So if your triangle does this, oh gosh, that's very not a triangle.
Okay, but what if you have like a triangle that's like...
Yeah, that's not good. So if you have this and you know this measurement here, you need to know this height here. Obviously, we're pretending that that's a straight line. So you need to know that measurement, which is often the reason we don't have it. Pardon? No, correct. But it has to hit the base length. All right, chill. So if we're trying to find the area of this triangle, we've been given nice, easy examples. We have two side lengths and we have the angle in between them. So all we have to do is say the area equals a half times 11.2 times 13.8 times sine 132. What modes should our calculators be in? Degrees. Yes. Not until IB do you need to change it. Okay, so I don't want it. You lot. And we're talking about area, so this one would be centimetre squared. No. Alright, next example. Again, I've nicely been given the two side lengths and the angle in between them, so it's just a matter of chucking it into the formula. So area equals.
You have all these formulas on the.
Yeah.
Okay. But we have to rearrange them?
Not for the area rule, no. So the only one you'd have to learn to rearrange is the cosine, remember? So the test that you have that sheet in every exam that you have. Okay, so you don't have to learn anything that's on there. The Pythagoras rule is even on there. Okay, so there are certain formats of right angle tree that we've done as well. So you do have formats of them, but my preference for the right angle tree is to remember slope half toe in the way that.
So do we have to put this for any brackets?
No, it doesn't need to be. Often your calculator, you may need to write time multiplied by sine 48. So if your calculator comes up saying it's an error, maybe that it needs a multiply sign. Yes.
I got 66, oh, 66, 662. 662, yeah, 66 points. Well, do you think that you don't need,
0.34?
No, because that's 3 something.
wait, I have a question about that.
What, tell me.
Okay, you can start me. I don't need any reference, that's fine. I thought we had this all on video.
Yeah.
I don't say it's word. You video your classes?
Okay, ask your question, Mia. Go.
Okay, so this will always be the same as the base.
Had you found the perpendicular height, so had you found either this measurement or this measurement, oh, you can see what I'm
So
saying.
they'll give you the same answer.
Yes,
So they each do each other. So like
Yes.
the same formula.
yes.
So what's this? Yeah, but what's the connection between the mixed stuff? Because sine.
What do you mean? What's the connection?
Okay.
I don't know this measurement. I don't have enough information
Yeah,
to
but like-
find this measurement. Therefore, I have to use this formula.
Yeah, but I just wanted to say if they give the same thing and they like both equal same things, there must be like some connection between the same thing. Like, is that formula not somehow work out?
Maybe. There's probably some like crazy math there. Yeah. Sorry, Mia. Normally, I'm quite unable to answer you, but quite frankly, this one I'm out. Sorry.
Sorry.
No, don't apologize. I'm sorry.
You probably need to turn off. I did.
Well done.
Just smack.
Okay, and you started the record as well. Alright, so in some questions you may be given the area of the triangle and asked to find the missing side of angle using the area rule. So for this one, we've got a nice little diagram. We know the triangle has an area of 20, and we know that angle PQR is acute. So I know that this angle here is an acute angle. Okay, so that's what I need to find. So they've asked us to calculate the size of it. So as with any question, if you're missing a part of something that you would usually use, then you're going to form an equation and then rearrange it. So my equation that I'm going to form is using the area rule. So I know that 20 is my area is equal to a half times 8 times 10 times 9 theta.
Minus.
Not minus. So 20 equals a half multiplied by 8 multiplied by 10 multiplied by sine theta. So I've set up an equation using my information I've been given. I now need to start rearranging stuff because my unknown is over here, so I need to move everything away from it. Now how you do that, we just talked about this, if we have a half of something, the easiest way to get rid of that would be to, bless you, I think, is to multiply both sides by 2. You could equally work out what 8 multiplied by 10 multiplied by half is. So you could do that as well. My preference is probably to work out what this is. So that's 40 sine theta.
Why do you have that too?
I didn't multiply by 2. I did a half multiplied by 8 multiplied by 10. So I worked out what they were.
Okay.
Okay? You're then going to try and find sine theta. So what are we going to do? What are we going to do? How are we going to rearrange
Oh,
it?
we're gonna move the first divided by the. No, move the 40 away from the.
Okay, so we're going to move the 40 away from the sine, so to do that we do the opposite, so we're going to divide both sides by 40. And I know that 20 divided by 40 is 1/2. Ooh. Alright, so we said, I think I'm running out of space. So we said that if we're trying to find the angle, which buttons do we use? Sine inverse. The inverse one, so I'm going to say that theta, oh gosh, that's not right. Theta equals sine minus half. Okay, which is 30 degrees. Alright, so we found that angle, and they then asked us to calculate the length of PR.
Wait, okay.
It's 30, isn't it? Okay, so if we're trying to find side HPR, we now need to say, okay, which rule are we going to use? We're trying to find this length here, so let's call this X. We've been given this side length, we've been given this side length, and we have an angle. So which rule is it? Is it sine rule or cosine? Okay, not many people are.
I don't know.
Okay, so how do we decide? Remember that the sine rule involves what? 2 sides, 2 angles, yes? So the sine rule is 2 of each. The cosine rule is 3 sides, 1 angle. And remember, when I say involves, you're going to be finding one of those things. So this one involves 3 sides, 1 angle, so that's, we know it's the cosine rule. Okay? Sorry, I took too much space a minute ago. In order to use the cosine rule, if we're trying to find this side length, we need to know the angle opposite it. Luckily, we've just calculated that. Okay? So we're going to have x squared equals x squared plus 10 squared minus 2 times 8 times 10 cos 30. And we're probably looking for a number around the 8, 10 mark. Okay, because if that one, if those two are 8 and 10, we're not going to have a length of 150. Okay, so again, always look to see, is your answer a sensible one? Alright ladies, so there is our answer.